Good morning. Today I'm going to be going over the AMC8 2019 practice test, number 24. In triangle ABC, point D divides AC so that AD to DC is 1 to 2. Let E be the midpoint of BD and F be the point of intersection of BC and line AE. Given that the area of ABC is 360, what's the area of EBF? So to solve this problem, we can use a technique called mass point geometry. It's actually based on the physics principle. So let's say in physics, we have a lever. And this is the midpoint of the lever, the fulcrum. Let's say on one side we place a 1 kg weight, and on another side we also place a 1 kg weight. So this lever will remain balanced. But what if we change this 1 kg weight to be a 2 kg weight? Obviously, it's going to try to sink on the right side. But is there anything we can do without increasing this weight to make it balanced? So the answer is actually yes. So if we were to extend this lever, and let's say the 2 kg weight is 1 foot from the center. Okay. If we were to place the 1 kg weight 2 feet from the center, okay, and I'm going to erase this one. The fulcrum will again remain balanced. So we can apply this in our geometry problems as well. So we're going to assign each point an invisible weight called a mass point. So A is going to have a point, C is going to have a weight, and we're going to treat it almost like a lever problem. So if AD to DC is 1 to 2, how can we keep these balanced? Well, we can assign a mass point of 1 to C, and we can assign a mass point of 2 to A. Okay, so even if AD, let's say it's x, and DC is 2x, by assigning mass points like this, the lever will remain balanced. And then we assign the middle point D the sum of the masses of its 2 points. So 2 plus 1 is 3. So this one will have a mass point of 3. Okay. And so let's get rid of those markings for now. And I'm just going to go and continue to keep assigning mass points based on what I know. So E is the midpoint of BD. So if it's the midpoint, then that means B also has a mass point of 3, because we're assuming this lever is in balance. Okay, and that means E has a mass point of 6. So what does that tell me about F? Well, then F has a max point of 4, because 3 plus 1 is 4, and also 2 plus 4 is 6. Okay, so what does this tell me about BF to CF? Well, it actually tells me BF to CF is equal to 1 to 3. Okay, so I'm going to label this as 3x, and I'm going to label this as x. That's because this mass point 3 times x should be equal to 3x times 1. And let me try to rebuild the diagram here. Okay, so this is point F. So using this information, we can already find the area of ABF. So how do we know what the area is? Well, we can see that the base BF is only 1/4 of BC. So therefore, the area is equal to 360, which is the area of ABC, times this ratio, 1/4. So ABF only has an area of 90. We can do something very similar to find EBF as well. So we know that F has a mass point of 4. let me erase